Okay, this is part 2 for the similar figures review. Part 2 of the review for similar figures. So part 1 went through 1 through 16. Part 2 is going to go through 17 through 27. Number 17 here says find the value of x that makes the triangle similar. So triangle ABC and triangle DEF. So we know A corresponds with D, B corresponds with E, and then C corresponds with F. So they're lined up well. We want to find the value of x, so we want to set up a proportion. We know the sides of similar triangles are proportional, so we can set up proportions. We know BC corresponds with EF. Okay. We know so the easiest way to do this, we're going to do it the hard way. And we know AC corresponds with DF. Okay. And we know that AB and DE. Okay, so we have x minus 1 over 18, 8 over 3 times the quantity x plus 1, and then 4 over 12. Okay. So the easiest way would be to pick these two, set these two equal to each other, and then solve for x. I'm going to do it the harder way, just so we get more experience with the algebra. So I'm going to pick these two. Okay. I'm going to cross multiply, so I'm going to have 3x plus 1 times x minus 1. Then I'm going to have 8 times 18. And it's much easier if you do x minus 1 over 18 equals 4 over 12. So I'm going to get 3. I'm going to get x squared. Okay, then I'm going to get minus x plus x. Right? I'm foiling, so first outer, inner, last. Right? X times x is x squared. X times negative 1 is negative x. 1 times x is positive x. 1 times negative 1 is negative 1. 8 times 18, that's 36 times 4. 72 times 2 is 144. I'm going to combine like terms. So 3x squared minus 1 equals 144. Okay. We can divide both sides by 3. Well, yeah. Well, make it easier, let's distribute the 3. So we'll have 3x squared minus 3 equals 144. And then let's add 3 to both sides. 147, that's 3x squared is 147. Now let's divide by 3. I know 150 divided by 3 is 50, so 147 divided by 3 is just going to be 49. So we have x squared equals 49. Take the square root of both sides, we get x equals plus or minus 7. Is plus 7 and negative 7 going to work here? No, because negative 7 times minus 1 is negative 8. You can't have a negative side length, so we're just going to stick with x equals a positive 7. If we put it back in, we'll have 4 over 12. We'll have 7 minus 1 is 6, so we'll have 6 over 18. That's going to work. And then we'll have 7 plus 1 is 8. 8 times 3 is 24, and then 8 over 24. This gives us 1/3, 1/3, 1/3. So we know we have the right answer. X is going to be 7. Uh, 18. So given that triangle ABC is similar to triangle DEF, Okay, if BC, so we got to draw it out. So we have triangle ABC and triangle DBF, right? A is going to correspond with D, B is going to correspond with E, and C is going to correspond with F. BC is 24, EF is 9, AC is Y plus 10, and DF is Y. Okay, we want to find AC, so we're going to have to find AC, so we want to find Y and then substitute it back in to find the length. Okay, so let's set up a proportion, BC and EF, right, corresponding sides, and then AC and DF. Okay, so that's going to give us 24 over 9 and Y plus 10 over Y. Cross multiply, we'll get 24Y. We'll get 9Y plus 10. We have to distribute the 9. Okay, so it's going to be 9Y plus 90. Subtract 9Y. We get 15Y equals 90. Divide by 15, and we get Y equals 6. Okay, let's plug it in. 6 plus 10 is 16. So AC is going to be 16. We can check. So 16 over 6 should equal 24 over 9. 24 over 9 should equal 16 over 6. This is going to reduce it. We divide by 2, we're going to get 8 thirds. Divide by 3, we're going to get 8 thirds. Okay. So we know we have the right answer. Y is 6 and AC is 16 because we substituted back in. 6 plus 10 is 16. Okay. Number 19. Okay, number 19. Again, we want to draw our triangles, ABC. We want to draw the next one in the same corresponding order. So A corresponds with D. So we want to put D down here because A and D are corresponding, B and E are corresponding, and then C and F are corresponding. Okay, AB is 7x, BC is 4, DE is 7, and EF is x. Okay, so 7x over 7 is going to equal 4 over x, right? AB corresponds with DE and BC and EF. BC and EF, AB and DE. Cross multiply, we get 7x times x, and 7 times 4, so we get 7x squared equals 28. Divide by 7, we get x squared equals 4. Square root, we get x equals plus or minus, nope, just kidding, we get x equals, yeah, plus or minus 2. Okay, but if we notice EF is x, so then we could say that's 2 or negative 2, but it can't be negative 2 because you can't have a negative side length. So we have to abandon the negative 2 and just say x equals 2. What's the question asking for? Determine the length of AB. What's the length of AB? So AB is 7 times 2, which is 14. So 14 is to 7 as 4 is to 2. So 2 equals 2. So we're good. We know we have the right answer. AB equals 14. 7 times 2. Substituted in for x. 2 for x. 7 times 2, 14. All right, number 20. Okay, number 20. Draw it out. Draw it out. A, B, C. Before I even read it, draw it out. So I see. Looks like I got to draw it out. Draw it out. D, E, F. And same thing. A corresponds with D. B corresponds with E, and then C corresponds with F. Okay. D, E is 4. A, B is X. A, C is X plus 2. And D, F is X plus 6. Okay, so AB corresponds with DE, just like the last one, and then AC corresponds with DF. Okay, so we have X over 4, and then we have X plus 2 over X plus 6. Okay, cross multiply, so we have X times X plus 6 equals 4 times X plus 2. X, distribute the X, so X squared plus 6X equals, distribute the 4X plus 8. Okay, try to move everything onto this side. So I'm going to subtract 4X from both sides. And we get X squared plus 2X equals 8. Subtract 8 from both sides. X squared plus 2X minus 8. I want to factor this. So how about X plus 4X minus 2? Right, you guys can use your fancy X method, right? Or what is it? 2 and 8. What do you put here? 2 and 8? 2 and negative 8? What adds to 2? Or do you put it up here? I think you put it up here. 2, negative 8. What adds to 2 and multiplies to negative 8? So we said a positive 4 and a negative 2. I don't really understand what the point of putting the X is, though. It's just simply what adds to 2 and multiplies to negative 8. Anyways, we get X plus 4 equals 0 and X minus 2 equals 0. Subtract 4. X equals negative 4. Add 2. X equals 2. Again, we can't have a negative side length, so we can't have negative 4. So our answer is going to be X equals 2, but we're looking for the length of AB. So the length of AB is 2. Okay. So just to reiterate here, we would have 2 over 4. This would be 4. This would be 8. So 2 over 4 equals 4 over 8. That's 1/2 equals 1/2. So again, we know we have the right answer here. My handwriting is not terrible. I just have to write bigger with the pen, which is probably something everyone wants anyways. 21. 21 is a good one. AB is 10. CD is 18. Find the lengths of EB, BC, and AC. Oh, because it's the midpoint, so it's going to be half. Yeah, we'll probably shouldn't put this one on there. It's going to be half. It's the mid-segment theorem one. We didn't talk about the mid-segment theorem. So anyways, that's going to be 9. So let's just call that 9. So let's say EB equals 9. That'll be part of our problem. So that's a comma, and then and EB equals 9. Now we want to find those two. Okay, well, we know BC is also 10, so we know AC is going to be 20, right? So let's draw them out. A, E, B, we know is 10 and 9. Okay, then the large triangle, A, BC, we know is 18, and we know this side's going to be 20 because 10 and 10, right? If they're congruent, if AB is congruent to BC, they're both 10. Okay, so if they're both 10, the whole thing is 20. So it doesn't really help us out. BC is 10, AC is 20, and BC is 10. Oh no, wait, never mind. Wait, hold up. I lied. Let's go back and yeah, that's what the whole point is. So we don't know this is 9. Okay. But we know since AB is okay. Let's start over. Okay. So AB is 10 and CD is 18. So let's draw out our small. I gotta draw it first. I thought we ABE, and then we have ADC. Okay, we know AB is 10. We know DC is 18. Okay, BC has to also be 10 because these AB is congruent to BC. Okay, that means AC, the whole thing is 20. So we know BC is 10. We know AC then is 20 because AC equals AB plus BC, right? AC equals 10 plus 10, so it equals 20. Okay, 10. We knew BC was 10 because these are congruent with AB. So now we want to find EB. We'll call that X. So it's going to be 10 over 20 equals X over 18. 18 times 10 is going to equal 20 times X. So that's 180 is 20X. Divide by 20. We get X equals 9. Okay, X equals 9. So EB equals 9. Yeah, we'll just leave it there. Since these are midpoints, we know that that's going to be half of EB, but we didn't talk about that, but that's fine. We found it to be 9. Okay. 22. So we got the word problems now and then 2 proofs. 4 word problems and then 2 proofs. Right. So a 5'9" man cast a 6'6" shadow at the same time of day. A tree casts a 50-foot shadow. What is the height of the tree? So we're trying to find the height of the tree. So that's going to be X. All right. We know the how many inches are in a foot. So there's 6 inches in a foot. So we know 6 foot 6 inches is going to equal 6.5. Make that bigger. 6.5 feet. Okay. So this is 6.5 feet. Okay, and then 5'9" inches is going to be 5.75 feet, right? Because there's 9 inches for every 1 foot. There are 12 inches. So we get 9 over 12 equals 3 over 4, which equals 0.75. So 5.75 feet, 5.75 feet is how we convert 5'9". So his height is 5.75. Okay, So let's set up our proportion. 5.75 is to x as 6.5 is to 50. Cross multiply. 5.75 times 50 equals 6.5. X. So 5.75 times 50 is 287.5 divided by 6.5 is going to give us 44.2. So the height of our tree is 44.2308. The height of the tree. Okay. That makes sense because it's a little less than the length of the shadow, right? And the man's height is a little less than the length of the man's shadow. So looks like it's about right. I'm sure if we plug this in, 44.230, we can plug it in. Divided by 50, it's going to give us 0.8846. And then 5.75 divided by 6.5, it's going to give us the same thing, 0.884615. Okay, so we know that's the right answer. 23, a tree stops a surveyor from directly measuring the length of a lot line. Okay. She locates points E, F, G, H, and I as shown. What are the lengths of E, F, and G, H? So I'm going to call this X. I'm going to call this Y. We'll say the length of EF is X, and the length of GH is Y. Let's set up a proportion. So 12, right, is our shorter side. It's going to correspond with the 20. So we're going to have 12 over 20. We're going to have 18 over X. And then we're going to have Y over 24. Y over 24. So I'm just going to pick the first two. Right? So 12 over 20 equals 18 over X. Let's cross multiply. We get 12X equals 20 times 18. 20 times 18, so 20 times 5 is 100, so that's going to be 360. Divide by 12. We know 12 goes into 6 30 times, so we know 360 divided by 12 is going to be 30. I can do 12 over 20 and Y over 24, so 12. So this is part of this one. 12 over 20 and Y over 24. I pick any of the two ratios I want and set them equal. So 12 over 20 and Y over 24. 24 times 12 when we cross multiply, and 20Y. 24 times 12 is going to give us 288. We're going to divide by 20. We get Y equals, 72.2 probably, 288 divided by 20, control enter is, 14.4. I don't know what I was thinking. 14.4. Okay. So, 14.4. Okay, we can plug it in to make sure it works. So 12 over 20, 18 over 30, and 14.4 over 24. Okay, that's going to be 3/5. That's going to be 3/5 if you divide both by 6. And then 14.4 divided by 24 is 0.6, which is 3/5. Okay, so we know we have the right answers here. So lengths of EF are 30 and 14.4. Right? 30, 14.4. Right, number 24. Leonardo da Vinci's famous portrait of the Mona Lisa is 30 inches tall and 21 inches wide. Okay, so here's the Mona Lisa. It is, oh God, why are we doing this again? I hit the button too hard, or? Okay. So it is 30 inches tall, 21 inches wide. Has a postage stamp to the model that is similar to the original painting. So then we have a postage stamp that the height is 4 centimeters. What is the width? Okay. So again, if you're drawing this out, it should be pretty easy. Okay, the heights are going to be corresponding sides, and the lengths, or the widths are going to be corresponding sides. So we're going to have 30 over 4 is going to equal 21 over x, right? 30 is to 4 is 21 is to x. Cross multiply, we get 30x equals 4 times 21. So 30x equals 84. Divide by 30, we get x equals 2 point something. 2.67, right? 84. What is it? Control enter. 2.8. So the width of the stamp is going to be 2.8 centimeters. 2.8 centimeters is the width. Okay. The clever outdoorsman whose eye level is 2 meters above the ground wishes to find the height of a tree. He places a mirror horizontally on the ground 20 meters away from the tree, 20 meters from the tree, and finds that if he stands at point C, which is 4 meters from the mirror, which is point B, he can see the reflection of the top of the tree. How high is the tree? So he's 2 meters tall. He's 4 meters away from the ladder and from the mirror, and the tree is 20 meters from the mirror. Okay, and the height of the tree is what we're looking for. So 2 is to x, as 4 is to 20. Cross multiply, we get 4x equals 20 times 2. So 4x equals 40. Divide by 4, and then x is going to equal 10. 40 divided by 4 is 10. So the height of the tree is 10 meters. 10 meters. It's not that tall of a tree, but it's not that short of a tree. 5 times the height of the man, right? 2 times 5 is 10. 4 times 5 is 20. 10 times 1/5 is 2. 20 times 1/5 is 4. And last two are the proofs. So 26 and 27 are the proofs. Right, so steps and reasons. 2 columns. First one is always the given. So what's given to us here is that NO over QO is equal to, is this the same one we did in class? Where it should be MO over PO. So cross that off and write MO over PO. Okay, and that was given. Okay, first thing we want to look for here, vertical angles, right? We have 3 ways to prove the triangles are, well, I don't want to go into too much detail. If you need more details on the proofs, go see the proofs video. Okay, but we'll want to look for vertical angles. So we have vertical angles. Middle here. So NOM, angle NOM is going to be congruent to angle QOP, okay, by the vertical angle theorem. Let me write it down here. Vertical angle theorem. So the first statement here is telling us we have two ratios of corresponding sides that are equal. So since we have two ratios that are equal of the corresponding sides, we know that two sides are proportional. Okay, so this is two sides that are proportional. So we have a side and a side. Here we have a pair of congruent angles. So we have an angle. So we know we have two sides of an angle. So we're going to want to use side angle side, which is side angle side similarity. Side angle side similarity, which is great as long as the angles between the proportional sides, and it is. So we can use side angle side. If we have two pairs of sides, two corresponding sides that are proportional, and one pair of angles that's congruent, one pair of corresponding angles that's congruent, then the triangles are similar by side angle side. So triangle MNO is similar to triangle PQO. Pretty straightforward there. Okay, 27 steps. Reasons. So we want to start with the given. Here we're given that MQ is parallel to OP. MQ parallel to OP. Again, this one was triangle PONO. It was a mistake. So first thing we want to look for are vertical angles. We have vertical angles right here. So angle MNQ is congruent to angle PNO, okay, by the vertical angle theorem, vertical angle theorem. Again, we want to use our given. So we were given parallel lines, right? We have parallel lines. Okay, when we have parallel lines intersected by a transversal, the alternate interior angles are going to be congruent. Okay, so here are the two lines. Okay, here's our transversal. So our alternate interior angles are going to be congruent. So angle Q is congruent to angle O, or we could do angle M is congruent to angle P. And the reason there is the alternate interior angle theorem. Okay. Alternate interior angle theorem. We have here one pair of congruent angles, and here a second pair of congruent angles. Okay, since we have two pairs of congruent angles, two pairs of corresponding angles that are congruent, we can use angle-angle similarity. So angle-angle similarity is going to tell us that the triangles are similar. If we have two pairs of angles, corresponding angles that are congruent, then the triangles are similar. So triangle MNQ is similar to triangle. Again, we said there's a typo, it should be PNO. Right, MNQ, PNO. And that is the second part of the review. So if you have any more questions, we can answer them in class on Tuesday, assuming you do this over the short midwinter break.